Welcome back. Now we'll look at paper 42 of May-June 2024. And as always with the paper 4 practical, well, we're going to need the source files and also the evidence doc. So if you don't have this, well, of course, just search the syllabus number on any past paper website. Of course, find, the correct year, the correct series. And you should be able to find these files quite easily. And as always, of course, well, we can code either in Java, Python, or Visual Basic. And if you saw the first video, well, again, I'm going to code in Java, right? Although I will also have Python and Visual Basic answers on the side of the screen. Hopefully the video will still be useful, right? Even if you're not doing Java. This first part is really just introduction. So I think let's just start reading here from 1. Right, it says a program outputs the main word. The program asks the user to enter the different words of 3 or more letters that can be made from the letters in the main word. Okay, these are called the answers. There are 3 files, right, easy, medium, hard, and each file has the main word on the first line. For example, the main word in easy txt is house. So I've gone ahead and just loaded these in already. So if we look here then, as I said, the main word is house. And then what it's saying, from these letters, right, H-O-U-S-E, right, then of course, we can make, for example, shoe, we can make use, right, we can make, like he's, right, she, so all of these words. So it says, right, easy txt therefore has 14 answers because, 15 total, right, 1 is, of course, the main word. Right, the words read from the text file stored in the global array word array, the number of words that can be made from the letters in the main word is stored in the global variable number words. Right, the procedure read words takes a file name as a parameter, opens the file and reads in the data. It's going to store the main word in the first element in word array, stores each answer in a new element in word array. Then it's going to count and store the number of answers. Okay, and we want to write program code for the procedure read words. Right, so let's just go ahead and do that, and I think I should have copied this already. If we just go ahead and make the main method, let me just paste this here as well. Okay, so it's saying, right, the procedure read words, and maybe I'll do it underneath. So to create a procedure, let's go, right, public static void. Right, this is going to be read words, and it says it takes a file name, right, so a string parameter. Okay, so, right, it's going to open the file and read in the data. Now, the problem with this, that if we look, here, easy, right, this has 15 words, right, medium has, 45, and then, hard, right, that has 98. Now, I suppose, we could just make the array size 98, although it's possible in future, they might have different words with, of course, more, more valid answers. So I think what I'm going to do, and maybe this is not necessary, but I'm going to loop through the file one time just to count how many words there are. Right, then when I've done that, I'll then make an array of that size. Right, then I'll read the file again, right, loop through line by line, and then of course we'll just assign each word, right, to the correct position in the array. And I suppose actually it did say we also need. I suppose we do also need to create this word array and number words. So since they're global, then let's go static, and right, this is going to be a string array. Right, this is called word array, I think. And at the moment, I'm not actually going to initialize it with anything because, again, we don't know how many words are in this. Obviously we don't know the size of this word array. Right, the next one, that's going to be an int because this is number words. And I suppose if we want, we can initialize this to 0, although again, of course, we're just going to be counting in the number of words in this read words. Right, so let's just go ahead and open the file then. So we're going to use a buffered reader. Right, let's go vr, and let's go right equals new buffered reader. Right, then we need to go new file reader, and then here we say the file name. Okay, just like that. Now we could write the try catch ourselves, but I'm just going to let IntelliJ handle it. So let's go surround with try catch. Right, so that's gonna, that's gonna create the buffered reader to read the file. Then what we want is, let's have a string variable, and we can call this line. And again, we can just let's say declare that. I think we don't really have to initialize. So what we want to do, in order to read line by line, kind of like pseudocode, basically we go sort of like while not end of file. So in Java, that's going to be, we go, line equals, right, this is br.readLine. and we check, well, while this is not equal to null, right, then of course that means, yeah, there's more lines to read. And here again it's going to say, well, we need to add, yeah, let's go add catch clause. So of course, well, this catch is, yeah, file not found, so of course that's going to be this buffered reader. Yeah, this next one, IO exception, right, that's going to be if we're trying to read the line. Okay, so yeah, let's think then. I mean, first then we just want to count how many lines there are. So I suppose actually that's just going to be number words. And let's make sure just to reset this number words to 0, because otherwise what might happen is, well, let's say we read, you know, this easy txt, right, this is going to have 15, right, then if we read medium, okay, without resetting to 0, then of course well, it's going to be, you know, 15 plus 45, so it's going to think we have, you know, 60 words. Yeah, that's why we want to reset to 0, because of course, well, each new file, yeah, we're obviously starting the word count from 0 again, right? Otherwise, we'd be counting the previous words from the previous files. So here then, well, I mean, each line we're just going to go, right, number words plus plus. And I think then we can just do what br.close. Yeah, so okay, take file name as parameter, yeah, opens the file, reads in the data. Right, so I guess here then, well, now is where we want to, let's say, create the word array, right, of the, let's say, yeah, of these dimensions. So if we go word array, that's going to be, well, new string array, and then here what these size will be the number of words. And then like what I'm going to do, actually, I'm just going to copy this. Yeah, so let's just copy all of this. Like, honestly, I think we probably... Yeah, I don't know. I mean, there's probably a method like, you know, br.reset or something. But yeah, I'm just going to create it again. Right, I mean, this string we can also just delete that because, well, we've declared that already. Right, number words we can also delete that. So what we want to do then, and I suppose we're going to want an index because we need to know like what index in the array to insert this current word into. So right, let's go. Yeah, maybe let's do it under here. I mean, let's go what index, or yeah, current word. Again, well, that's going to start at 0. So what we're doing, if we just go right word array, this is then going to be at the index, and we're then just going to assign it this line that we've read, and of course then we just want to make sure to increment the index like that. Okay, so store, yeah, each answer in a new element in the word array. Yeah, counts and stores the number of answers. I mean, yeah, okay, so I think we've done that. Yeah, I mean, so I think, yeah, this one then we've done everything. Counts and stores the number of answers. Yeah, because I think, I mean, here they're not asking us to actually output anything. So yeah, I think that's fine. Right, then, well, yeah, then of course, I mean, in the real exam, just copy and paste the program code right into the evidence document. Although, you know, for this video, I won't be doing that. Right, the main program asks the user to enter right, easy, medium or hard and calls read words with the file name that matches the user's input. For example, if the user enters easy, the parameter is easy txt. Okay, so again, right, let's just copy this. And if we notice, yeah, let's just paste it here. If we notice, right, so here, you know, this is a lowercase e, but then actually the file we're reading is going to be, well, this big E. So I think what I'm going to do, I'm just going to convert the user input to lowercase, and then, yeah, what I'll probably have is just an if statement. So I say, let's say, you know, if user input, right, to lowercase, yeah, equals, right, this lowercase easy, right, then the file name equals, well, yeah, this string. So in order to get user input, well, let's go scanner, let's go sc, yeah, I mean, you can call it scanner, right, it doesn't really matter. Right, so this is new scanner, and then we go, right, system.in. Right here, well, I mean, let's just go output, so s out, and we'll just say, well, enter, maybe, yeah, like enter difficulty. Yeah, I think that's fine. Right, and then what we can do, let's make a string variable, and I mean, I guess, yeah, we'll just call it, what, difficulty, or like user choice. And then, right, so here, then this is going to be xc, yeah, sc.next line. And then, I suppose, actually, we can also convert this to lowercase here as well. And I mean, well, then we can then just have an if statement. So, right, let's go if difficulty. And I mean, probably we can also do this with a case if we want. But, right, let's go, yeah, difficulty.equals. And if this is equal to easy. And of course, remember now that, well, since we've converted it to lowercase, like, of course, yeah, even if they type in, I don't know, you know, something like this, right, well, of course, yeah, that's going to be converted right to this lowercase. So yeah, that's fine. Right, then I guess what we want to do, I mean, we can, let's maybe go string and we'll just call it file name. Yeah, let's just set that to an empty string to start with. So in this case then the file name is going to be what easy.txt, and then yeah, let's have the semicolon. Right, then what I'm going to do, I'm just going to copy it because, well, basically it's going to be the same. And let's go, yeah, else if, and then maybe we can have an else, right, just for like an invalid file name. Notice here IntelliJ is saying, well, yeah, these if conditions are the same. So let's go medium, let's go hard. And, you know, this is the good thing with IntelliJ as well, is it's going to give you a lot of like code suggestions. Right, okay, and then here I guess, well, let's go s out, and we'll just go, I don't know, like invalid file name entered. Or, okay, well, let's say, yeah, invalid difficulty chosen. Yeah, so I think that's fine. And I mean, like, yeah, I don't know, I guess if we want, we could have a boolean, which is just going to determine, right, if it's valid or not. So we could go, I don't know, yeah, like is valid, maybe is valid difficulty, or yeah, is valid file name. Now let's just set this to true by default, and then, you know, these we can just do nothing. But if we go to this one, well, let's go is valid difficulty equals false. And then outside here, let's just check that. Although, yeah, I mean, I think, to be honest, right, they didn't ask us to do this in the question, so I think really this validation is probably not required. Yeah, although I mean, they shouldn't really like penalize you marks, right, if you do this. Right, so if is valid difficulty, well, then we just want to go read words. Yeah, okay. And then here, right, that's going to be the file name. Yeah, was that all we need to do? Yeah, okay, so I think, right, that should be fine. Okay, right, then the procedure play, this will output the main word from the array and the number of answers. It's going to allow the user to enter words until they've entered the word no to indicate they want to stop. It's then going to output whether each word the user enters is an answer or not an answer. It's going to count the number of answers the user gets correct and replaces each answer that the user gets correct with a null value in the array. Okay, and then, yeah, we just want to write this procedure. Right, so again, let's just copy this, and yeah, let's just do it maybe here, right, under the main. Right, so again, it's a procedure, so, well, let's go, right, public, yeah, public static void, right, that's play. This one has no parameters. Right, so first we want to output the main word from the array and the number of answers. So the main word, well, that's just going to be index 0. And I guess, yeah, let's just call this one main word. I think, yeah, that kind of makes sense. Right, that's going to be the word array at index 0. Right, then the next one, this is the number of answers. And then the number of answers, well, that's just going to be, I guess, well, number words and then -1. Because, of course, if you think, well, yeah, the first element in the array is just the main word, right? Therefore, yeah, the number of answers is, well, the number words -1. Right, then we're going to allow the user to enter words until they enter the word no to indicate they want to stop. So again, well, let's go scanner, right, sc, right, new scanner, yeah, system.in. I think for this, right, I'm probably going to use a post-conditional, right, although, yeah, you could also use a pre-conditional loop if you wanted. Yeah, it doesn't really matter. And, I mean, let's first think then about the stopping condition. So, and I guess we're probably going to want a string variable. We can call it, I don't know, like user input. Yeah, let's just make that an empty string to start with. So here then what we want to say, while user input, and let's go right equals no. But of course, well, you know, we want this to be false, right? So we just go not. So what we're going to do, well, we're going to loop, right, while the user is not equal to no. Right, and then what do we want to do? We want to output each word the user enters is an answer or not. Okay, so let's just, yeah, I guess let's just prompt them. Maybe, yeah, enter guess. Right, and then, yeah, so here then this is going to be user input, and it's going to be what sc.nextLine. Okay, and then I suppose what we need to do, well, we need to loop through the array to check. I mean, well, basically just a linear search, right, if it exists or not. So let's make a boolean for that, and we'll go like, yeah, is valid, or yeah, is valid word, and right, I mean, let's give that the default value of false. Now, what we're going to do, we want to think, well, we don't want to include the first word in the loop. So rather than starting, let's say index equals 0, we're going to start this at 1. Because of course, well, let's say easy, right? If they enter house, well, house is just, of course, yeah, the first word, right? So I mean, well, obviously we don't really want to include that as the answer. Right, then we want to go, right, index is less than number of words, and again, well, just index plus plus, right? Just a simple for loop. And what we can do, so let's go if, and we'll check if the user input, and I think this can probably be, I mean, I suppose if we want, we can go to lowercase. So right, let's check if that's equal to, and what this will be the word array, and then what the current index. And I mean, this we don't really have to convert to lowercase, because if we see, well, I mean, they're all lowercase anyway. Right, so if it is equal, well, then we can just go, yeah, is valid word equals true. And actually, yeah, okay, I mean, I guess we do need this really. Right, so we want to output whether each word is an answer or not an answer. So I suppose here, well, let's go, I mean, what we can just say, yeah, okay, right, word array index, and we'll just go like is correct. Right, then we want to count the number of answers the user got correct. So here then, and make sure, I mean, don't declare this loop in, don't declare this integer inside the loop, because well, otherwise that's going to get reinitialized to 0 every single iteration. So yeah, this should be declared outside of the loop. Let's go, I don't know, like, yeah, maybe num correct, or yeah, correct count. Right, so the num correct, of course, that's going to start at 0. Then if we get it correct, well, let's just go, right, num correct plus plus. Now, I mean, we can just continue looping like this, right, or we can just use a break statement. What a break statement will do is, well, when it hits this break statement, okay, then it's just going to exit out of the for loop. And I think, yeah, IntelliJ actually kind of matches them, right? So if we highlight this break, you can see, well, that's saying we're obviously, yeah, breaking out of this for loop. Right, so we also want to replace each answer the user gets correct with a null value in the array. Okay, so let's make sure just to do that then we go word array index, and right, that's then going to be equal to null. I mean, if you wanted, you know, you could just have an empty string like this, but I think I'm going to do null because, well, the thing is sometimes an empty string obviously is a valid string. Although note, right, if we do make it null, then if we do, for example, word array, you know, index, right, dot to lowercase, well, that's going to give us an error because it's going to say, well, I mean, yeah, I guess let's say what, like, to lowercase is not a method, right, of null. Yeah, we're just going to get a null pointer exception. Okay, and then, yeah, like, is that all we need to do? So outputs the main word from the array number of answers. Okay, yeah, we've done that. And to be honest, in the exam, like, if I was writing this, I would just tick off things as I've done it. So yeah, maybe I'll just delete it once I've done it. Right, allows the user to enter words until they enter the word no to indicate they want to stop. So yeah, I think we've done that as well. Right, outputs whether each word they enter is an answer or not an answer. Well, we've done some of that. I guess we just need to output if it's incorrect. So to output if it's incorrect, well, let's make sure to do that outside of the loop. Because, I mean, some people might think, well, we can do an else here. But of course, like, this will output, let's say, every word that's incorrect. Like, if, for example, I don't know, maybe they enter use, well, then it's going to check Hughes, and it's going to say, well, yeah, Hughes is incorrect, or hose is incorrect, you know, this is incorrect. Whereas, yeah, obviously, like, we just only want to output at the end, right, after it's checked all of the words. So that's why we have this Boolean. So let's go, yeah, and I suppose right here then, this is why, okay, hang on, right, it's not going to be outside of that loop, it's going to be outside of the for loop. Right, so let's go, yeah, if is valid word equals false, and I'm sure here it's going to say we can simplify this, so yeah, we can just simplify right with the yeah, exclamation. Right, and then let's go s out. And then in this time, what it's going to be user input, and let's just go, I don't know, like, was not correct. Yeah, or yeah, was incorrect. Yeah, so I think that's okay. And I mean, here it doesn't say we need to output the number of correct answers, right? Maybe that's going to be on the next question. Right, then it says amend the procedure place so that when the user enters the command to stop the procedure, right, it's going to output the percentage of answers the user entered from the array, and also outputs all the answers that the user did not enter. Okay, so yeah, right. Let's try and do this then. Right, and it said obviously, well, we should do this right after they stop. So yeah, after this do while loop. Right, so to get the percentage of answers they entered from the array, I suppose what we can use the num correct, and we can also use what the number words minus one. So I mean, let's go like, well, let's make it a double. We'll go percentage correct, and again let's make sure. So right, hang on, then this is going to be what is num correct? I think I called it. Right, so it's going to be num correct, and then it's going to be what divided by the number words minus one. Now, if you notice here, it's going to give us an error, and well, I mean, just a warning really. And the reason for that is, well, let's say we have, I don't know, 5 correct, and we divide that by, let's say, for example, 10. Well, the thing is, I mean, in Java, if you have an integer divided by an integer, right, then that's going to equal an integer. So in this case, 5 divided by 10, well, that's just going to equal 0. If we had 15 divided by 10, well, that's going to be 1, right? So basically, it's just doing integer division. Now, the way we get around that is, well, we can just cast this number correct to a double. And now what that's saying is, well, this number correct is, converted, right, casted to a double. And then when we have a double divided by an integer, right, that's going to be a double. Likewise, of course, double divided by a double, right, that's also going to be a double. Yeah, so I think that's fine. And then I suppose if we want it to be a percentage, well, let's multiply by 100. And yeah, we'll just put all of this in brackets, right, and then do the multiply by 100 at the end. So let's go s out, and we'll just say what, like, percentage correct. Yeah, I mean, it's not necessarily the percentage correct. I mean, it's obviously the percentage of all the words that they got, I guess. But I think, I mean, call it percentage correct is fine. It doesn't really matter. And right, that's just going to be percentage correct. And then I'm also just going to add, I'm just going to concatenate the percentage sign. Right, then we want to output all the answers that the user did not enter. Alright, so I guess we can check that. I mean, like, we don't really have to do an if statement, but we can say, what if the number correct, let's say, right, if this is not equal to, right, the number words minus one. Although thinking about this, yeah, okay, I think that should work. Like, I was going to say maybe that wouldn't work if they entered the same answer twice, because, they would be given 2 points for having the same answer twice. But here, since we set this to null, well, then when we do user input to lowercase equals, right, word index, word array index, of course, well, this is now not going to be equal, right, because this word array index will be null. And yeah, of course, well, the user input is not going to be null. Because, like, I mean, even if the user just doesn't enter anything, well, that's going to be considered an empty string, right? And of course, an empty string is not going to be equal to null. So yeah, I mean, that's the benefit, let's say, of doing null, right, rather than just doing an empty string for this one. Right, so yeah, what error is it giving us? Okay, yeah, just empty body, right. So here then, well, let's just loop through, and basically we just want to output, right, if the, if the current word is not equal to null. So let's do the same again, right, in index, that's going to start at 1, right, then we go index is less than number words, right, then we're going to go, index plus plus, and then here let's go if, so we say, right, if the word array at this index, right, if that is not equal to null, well, then we're just going to output, and let's give a message, let's say, I don't know, maybe like didn't guess. And we'll just go, right, word array and index. Alright, and then I think that's everything. Right, so the procedure read words calls play at the after the data in the file has been read. Okay, so where is read words at the bottom? Right, so well, after we've read it, then I guess we can go here. Right, let's just go play. Now, I mean, like, if you, I guess, if you wanted to, like, you could probably put it, let's say here, right? Of course, well, if there's been no exceptions, right? Otherwise, you could have a situation where, well, the file doesn't exist, but then it's just going to catch the error, right? And then, of course, it would continue calling play regardless. But I guess, well, we only really want to call play if there's been no errors. Right, then test your program by inputting these words in the order shown. Okay, so let's just copy these. Right, let me just paste them maybe down here. Right, and then let's, okay, right, it's give me an error because, yeah, I've just got those strings at the end. Right, let's just run this then, and hopefully it should work. Yeah, well, as long as there's no silly mistakes. Right, so enter difficulty, I mean, well, let's just go easy. Right, okay, yeah, main word house, number of answers, right, that's fine. Right, so then we go she. Yeah, she is correct. What then, out? Okay, yeah, out was not correct, and no. Okay, alright, so yeah, no is going to stop. Right, percentage correct means 7%, and I guess what, yeah, 1 divided by 14, right, this seems correct. And then it's saying, right, didn't guess this, and then if we look, yeah, so she is not included. Alright, so I think that's working. Then of course, I mean, well, in the exam, you know, you can test this as well, but I think here it should be working. And of course, yeah, just take a screenshot as it tells you. Then number 2, a binary stores data in ascending order. Right, for example, like this. A computer program stores integers in a binary tree in ascending order. The program uses object-oriented programming, or OOP. The binary tree stores a 1D array of nodes. Each node contains a left pointer, a data value, and a right pointer. Right, the class node stores the data about a node. So, well, yeah, well, like I said, we've got left pointer, right, data, and right pointer, all integers. Yeah, so I think that's fine. And for example, stores the index of the node to the left in the binary tree. Right, then the methods, well, right, constructor, then just what getters and setters for each of these. And if we look at the constructor, it's going to initialize data to its parameter value, and it will initialize left pointer and right pointer to -1. Right, we want to write program code to declare the class node and its constructor. Do not declare the other methods. Right, yeah, use the appropriate constructor for your programming language. And if you're writing in Python, include attributes declarations using comments. So yeah, basically what just saying the attribute name and well, the data type. Okay, so yeah, I mean, well, let's just go here then, and right, let's go to question 2. Right, I mean, so I guess, I mean, well, let's just do the main, although yeah, we don't actually need that at the moment. So what we want to do, well, we want to create a new class. Now, I'm actually going to do it just all in one file. However, if you wanted to, well, of course, you could just go here, right, go, yeah, new Java class, and just make a separate file for the node. So right, this is going to be node, and then if we think, I mean, I think probably let's make them private. Yeah, maybe we'll have to make them, no, okay, yeah, so private is fine because, well, we've got getters and setters for each of these attributes. If we didn't have getters and setters, well, then we can make it public and access them. But yeah, since here we have getters and setters, right, we don't have to. So this is going to be int, and what the first one's going to be left pointer. Right, then it's going to be data, and right then it's going to be right pointer. And again, to be honest, you know, we can actually just go ahead and do everything. Like, in fact, yeah, let me go after this. So we can just right click, okay, we can go generate, and for example, let's go getters and setters. Now, of course, then you just, you know, select all of these. Well, it's just going to generate all of those. Yeah, I suppose actually, well, at the moment, right, we just want to create the constructor. Likewise, of course, you could do it for the constructor if you wanted, okay, right, automatically generate. But I'm just going to show you how to do it manually. So we go public, right, then we say the class name, then we say the parameters. Now, in this case, I think they said what the only parameter was going to be data, because, well, we're just going to initialize left pointer to -1. Also right pointer again, that's also -1. And then let's go data, and then, well, that's just going to be right equal to data. Now here, right, I guess we've got the same name, so either we make this, well, let's say a lowercase d, and then yeah, this can be a lowercase d, because what that's saying is, well, this data which we see here is this, you know, class attribute, and then obviously, well, we're assigning that with this, yeah, lowercase data, right, which is the parameter. Right, alternatively, you can just go this dot data, and then if we just make this data, yeah, and we also make this, right, sort of big D as well. Because, I mean, if we say, well, this dot data, then, I mean, well, this means, you know, some, well, let's say a class attribute or class method. Yeah, I mean, like, this just means, I mean, basically, well, sort of, you know, within the class, right, not a parameter, yeah, not a global variable, right, just, you know, yeah, just one of these, like, let's say, what, class attributes or class methods. Alright, so I think, yeah, that's all we had to do, right, just create the constructor. Yeah, okay. Alright then, well, the methods, right, get left, get right, get data. and then also the setters, right, set left, set right, set data. So I'm just going to do all of these in one go because, well, again, you can see it's pretty quick. So if we want to, again, I'll show you how to do one example manually and then I'll generate the other two. So let's just get the one for left pointer. So, well, let's go public. Since, I mean, a getter, it should always be public really, because, well, we probably want to call this from, you know, outside, right, from another, let's say another class. So right, a getter, well, this is going to be a function, okay, so we need the actual return type, right, that's going to be int. And then what we call it, get left. I think just get left, that's what they called it. Then well, here we just simply go return, and that's going to be left pointer. So yeah, pretty easy. Right, then we can do the same for the setter, but this time, well, it's going to be void because, well, this will be a procedure. And let's go set left. Right, this will take an integer parameter. I mean, let's call it left, right, lowercase. And then we just go, well, left pointer, right, is equal to left. So I mean, pretty much, you know, basically the same as what we did here for the constructor. Now again, like, of course, if we call this left pointer, you know, spelled the same as this, right, then of course we could also go this dot left pointer here. But yeah, since I've given it a different name, right, then it's fine. Right, so the other ones then, well, let's just generate them automatically. So if we go generate, and well, let's go, yeah, getter and setter, and then we only want to select data and right since we've already done left. Now, I mean, do just look at these carefully because, well, this one is, you know, get data with a small g, so I'm just going to go, you know, big G like that. Likewise here, get, okay, no, sorry, right, set data. And then I think this one is not get right pointer, okay, it's just get right. And again, yeah, let's go right, big G like that. And hang on, right, this should be set. Although the thing is, you know, let's say, for example, if I did make a mistake like get right. Okay, alright, so I thought IntelliJ would actually tell me that's wrong. But I suppose here this is actually method overloading. Because, well, this one has no parameters, right? This one does have a parameter. Now, I'm just going to check quickly. Yeah, okay, so right, if they both have no parameters, it's going to say we've got, you know, duplicate get right. But let's put that back and yeah, let's make sure that that should be set right. Alright, so yeah, I mean, that was not too difficult, you know, as long as you're just careful with the namings and things. Right, then the class tree class stores the data about the binary tree. So we've got what, tree, and that's going to be, what, 20 nodes. Right, then the first node, so like the first pointer, right, then the number nodes, the quantity of nodes in the tree. Okay, we have constructor which will initialize first node to -1 and number nodes to 0. It's going to initialize each element in the tree to a node object with the data value -1. Right, we're then going to insert the node, and it's going to take a node object as a parameter, insert it into the array, and update the pointer for its parent node. And right, then output tree will output the left pointer data and right pointer of each node in the tree. Right, then it says that nodes cannot be deleted from this tree, which actually makes it easier because, yeah, I mean, deleting can be a bit tricky. Right, we want to write program code, right, to declare the class tree class and its constructor. Do not declare other methods. And again, it's saying, yeah, Python, right, use the attribute declarations. Okay, so, right, let me just copy that because otherwise I'll probably forget these. So again, if we wanted, you know, we could make another file, but yeah, I'm just going to do it here, right, tree class. And yeah, let's just paste those. Right, so in this case then, I mean, probably let's make them, yeah, I mean here, so we actually don't have any getters or setters, so I'm going to make these public, right, otherwise we won't be able to access them. And then, right, this is going to be node, so it's a node array, and we call it tree. And, right, that's going to be what equals new node, and then 20. Right, then the next one we want to go, what, first node, yeah, and number nodes, and I guess I also need to give the data type. So right, let's go int like that. Now, to be honest, I mean, we could just, you know, assign this, what this was -1, and then, yeah, number nodes was 0. However, I mean, well, they tell us to do it inside the constructor, so I guess, yeah, let's just do it there. Right, okay, so, right, tree class, so if we just go public, right, tree class, and then I think here, what, there's no parameters. Yeah, I mean, there's no parameters, right, since, well, I mean, here it tells us all the values we need. Right, so it says that what we want to do then, we want to initialize each tree, or yes, or each node, with the data value 0. So here, well, we're just going to loop, let's go, what, index, right, that's going to start at 0. We're then going to go, what, less than 20, and if we go index ++, then what we want to do, we want to go tree right at this index, and that's going to be equal to right new node, and then wait, did they say -1? Yeah, data, right, so node object with the data value -1. Right, then it says, and hang on, right, let's not do it inside the loop. It says, right, we want to go first node, that's going to be -1. Okay, -1, right, if I can type. Right, then number nodes is going to be 0. Yeah, I think that's okay. Right, then the method insert node takes a node object, right, new node, as a parameter and inserts it into the array tree. Right, insert node first checks if the tree is empty. If the tree is empty, right, insert node stores the new node in the array tree at index number nodes. Then it's going to increment number nodes and store 0 in the first node. Right, if the tree is not empty, then it will store new node in the array tree at index number nodes. So I think if we notice, this is actually the same as this one. So yeah, this first one and this first one are the same. Right, then it's going to access the data in the array tree at index first node and compares it to the data in new node. Right, repeatedly follows the pointers until the correct position for new node is found. Once the position is found, insert node sets the left or right pointer of its parent node, and it's going to increment number of nodes. Okay, right, so let's copy all of this. And to be honest, I would say that probably binary trees will be the hardest thing in terms of, programming. Yeah, it's going to be probably, the hardest thing they ask in A-level. Well, yeah, I guess at least in my opinion. So what I'm going to do, I'm just actually going to demonstrate then how to actually do a binary tree. Just how to sort of, do it on paper. Now, let's say we have the values, I know maybe 6, right, let's say 2, 3, let's try maybe 7, 5, right, and 8. So of course, this is the order we're inserting them. So 6 then is going to be the root node. Now, if we see, we're going to check 6, and we're going to see, is 2 less than or greater than 6? Right, because it's less than 6, that means we need to go left. Now, in this case, we see that there's actually no, there's no, sort of like left child, right? There's no, left, left child, right, or left node. So because there's no left node, then we can just insert it here. Right, then we see 3. So again, 3 is less than 6, right? So this means we follow this left pointer. Then we compare 3 with 2. 3 is bigger, right? And of course, again, in this case, we see the 2 right node is also equal to -1, right? Just the null pointer, right? Therefore, we just insert it. Likewise, we can go 7. So obviously 7 is bigger than 6, and yes, 6 has no right pointer, so 7 goes here. Right, then 5. So 5 is less than 6, right? But it's going to be bigger than 2, and also bigger than 3. And then in this case, 3 has no right pointer. And then we're at 8, so 8 is bigger than 7, 8 is bigger than 6 and bigger than 7, again, right, 7 has no right pointer, so yeah, just add it here like this. Alright, so that's basically what we want to do, and yeah, we just want to try and code this up. So actually, yeah, where does it say this is going to be, is this in the tree class? Yeah, okay, so this is in the tree class. Right, okay, so yeah, this is going to be a procedure, right, because it doesn't return anything. So let's go right public void. Notice that, because we're inside a class, right, we don't need static. So let's go insert node. Right, then this takes a node as a parameter. We can just call it, I think what I said, new node. Yeah, right, new node is the parameter name. Right, now, because we said, here, right, this one and this one, so if it's empty or not empty, the first thing is just the same. Right, therefore, I think we can just do this, outside of any if statement. We want to go, right, so tree is the actual, okay, wait, not that one. Yeah, tree is the actual, list of all nodes, right, the array of all nodes. And then we store that at the index number nodes. And I guess at the moment, number nodes is just going to be 0. So yeah, this is just going to store, the first tree at the, or the, the first node at the moment. Right, that's going to be new node. Right then, yeah, I think we don't want to increment number nodes yet. Let's have an if statement. So we can check, to check if the thing is empty, let's go, right, if number nodes is equal to 0. Right, then if we look here, it says we want to increment the number of nodes. Because of course, as you can see right here, we've successfully inserted it. Right, then we want to store 0 in first node, because I think we said first node was -1, right? So now if we just set it to 0, okay, that's, you know, pointing to the first element in the array. Right, then we want to go else, and yeah, here this is a bit tricky. So what we want to do then, like probably we want a current node, or yeah, well maybe let's say a current node index. So yeah, let's go like current index, and then if we think, well, the current index is going to start at the first node, because, well, of course, you know, we're always starting from the root node and then going left or right to find the correct position. Right, so that's going to be first node, and then yeah, do we need, like, I think maybe let's just make a variable to actually store this new node value, right? Otherwise we always have to go, you know, new node dot get data. So let's go, yeah, maybe like new node, right, value, and that's going to be, right, new node, yeah, dot get data. Yeah, I mean, I think like maybe that's okay. I mean, let's try and code this, right, see if we need anything else. So I think, well, I mean, we want to loop while the current index is not equal to -1. Right, and then, I mean, well, let's think what we want to do first. So I guess what we actually want to get the current node, because yeah, I mean, well, so let's say at the moment we have the current index, but we don't actually have that node. So yeah, I mean, well, let's call this current node. And I think this one we can just, you know, start as being nothing, right? Just yeah, just, you know, sort of don't initialize it. Right, then the current node, well, that's going to be equal to, well, the list of trees. Then what that's going to be at the current index. And what we want to do, well, we want to check if the current value, so right, let's go, yeah, if the new node value is less than, and that's, well, let's say the current node, and then yeah, get data. So if it's less than this, well, this means we need to go left. However, we also have to think, well, what happens if the yeah, if the pointer is, you know, -1, right? If there's nothing there. So I think, yeah, okay. I mean, let's have another if statement here, and we'll go. Right, so we want to go if current node dot, yeah, get left, right? If this is equal to -1. Right, well, then it says what we want to update the pointer of this current node, and yeah, we also want to insert. I suppose actually, well, I mean, yeah, we've inserted this already, you know, at this position. Right, so what we want to say then, we want to, yeah, set the pointer to be this number nodes, because, well, this is, you know, the let's say the position of the new nodes that we've just inserted. So right, let's go, yeah, current node, and we'll go set left. And then that's going to be, right, number nodes. Yeah, I mean, is there anything else we need to do? And I guess, I mean, we also need to update this current index. So I think we can do that current index here. I mean, we could also do it after the if statement. No, okay, no, right, let's do it before the if statement. Because, yeah, otherwise we've updated this set left already. Because, I mean, what we want is, well, in this case, we want the, yeah, okay, so well, in this case, we want the current node, or, well, sorry, the current index to be -1, because, of course, well, this means it's just going to stop, right, once it's inserted this. Otherwise, the current index will be -1, right, but then if we sort of update the current index to be the new left pointer, well, the thing is, right, here we've changed the left pointer. So, yeah, we want to get the new current index, sort of, you know, before we actually, like, update it, right, before we, yeah, I guess just before we update it. I mean, hopefully this makes sense now. Yeah, like, honestly, I mean, I'm not 100% sure if this is going to work. Like, hopefully, yeah, hopefully it should work first time. Right, so current index, and that's then going to be, right, that's going to be the current, hang on, right, current node, and then, yeah, get left. So let's try and walk through this. So we say if the current node value is, okay, sorry, if the new node value, so, you know, the thing we're inserting, right, is less than the current node's data, well, this means obviously we're going left down the tree. Right, then we're setting the current index as being the current node, well, yeah, let's say the left pointer of the current node. So yeah, I mean, I think this makes sense, right? We're just, you know, going down the left branch of the tree. Right, then we're checking if the current node is, well, I mean, basically, yeah, if there's no sort of, you know, left child, then if there's not a left child, or if there's, yeah, not a left node, then we're just going to set the left node to be this new element. Yeah, I mean, I think that's okay. And then I guess after we've inserted it, well, let's just go like number nodes plus plus. And then what I'm going to do, I'm actually just going to test it just for the left node. And then, yeah, if this is working, well, then it's going to be simple just to copy and paste, you know, change a few things for the right node. But I don't want to try and make the right node because, well, if I have a mistake in this, then of course, well, I've got two places to fix the mistake. So what I'm going to do, I'm actually just going to create some test up here. So right, this is going to be what I guess we're going to want a new instance of this tree class. I mean, I guess, well, let's just call it like trees. Well, yeah, tree class, I think that's fine. Right, that's going to be what new tree class. And then, right, what happens when we create this? So, yeah, that's going to create what these 20 things. Right, then if we just insert a couple of nodes. So let's go, right, tree class, yeah, insert node. Right, let's go new node, and I mean, let's just try, for example, 7. And remember, in this case, right, we only want to insert things on the left. Okay, so they should be getting like progressively smaller. So let's try maybe 7, 5, and 4. Like if we tried 8, well, this is not going to work because, yeah, currently we've not implemented the right, the sort of, you know, right inserts. Now that's fine. I mean, you could, for example, add a breakpoint here. No. Okay, all right. So I realized, yeah, we can't add a breakpoint because, well, we don't have any code here. Right, let's just add that code and then, okay, right, there we go. And then, yeah, I'm just going to run this in debug mode. Right, hopefully there's no errors. Okay, right, that's still running the wrong program. Right, so let's, yeah, debug this one. Okay, I mean, so it seems like it's not causing an infinite loop, which is good. Right, then if we go into the tree class here, and actually is, yeah, okay, I mean, so I think this should be the tree class we're looking at. So if we look at thing 0, then, well, node 0, the left pointer is 1, okay, which seems correct. Yeah, then here, right, the left pointer is 2. And then here, right, the left pointer is -1. We can see that the data, right, 7, 5, and 4. So I think, yeah, I think this is working. And then what I'm going to do, I'm just going to close it quickly. And then basically, I mean, for the right node, it's going to be really easy. We're just going to go else if. And then we're going to change this to be greater than. And then where it says get left, well, we're just going to go get right. And then, of course, yeah, here, let's go set right as well. Yeah, so I think that should be fine. And then let's just go back and see what the next thing is we need to do. Right, the method output tree outputs the left pointer of the data and the right pointer for each node that's been inserted into the tree. The outputs are in the order that they are saved in the array. So I guess, I mean, this is what just the order that we insert them, right? Obviously, yeah, sort of, let's say like node 0, node 1, node 2. Like, I don't think it's asking us to output them, let's say in ascending order, right? Obviously, like, yeah, let's see this, you know, sorted order in the tree. It's just asking what the order that we inserted them. Right, if there are no nodes in the array, the procedure outputs no nodes. Okay, so yeah, let's copy this. Right, so I mean, does it say this is going to be right? Okay, yeah, this is a method on right in the tree class. Okay, so where is the tree? Okay, here we go. Right, and then again, well, let's just go right public void, and this will be output nodes. Was it output nodes or maybe output tree? Okay, right, no, output tree. Right, that's going to output the left pointer, the data, and the right pointer. So actually, this one is quite easy because, well, we can just have a simple for loop. Right, let's go, yeah, in index. And I suppose we do actually just want to check if it's empty. So, I mean, to check if it's empty, well, we just go, right, if number nodes equals 0. Well, I mean, or we can just go greater than 0, right? I mean, let's have the sort of common case first, and then we'll have the else here. So this else, well, this will be, well, just no nodes. Right, and then if it's here, well, let's just copy this for loop that I was about to write. Right, let's uncomment that. Yeah, just sort of de-indent it. Right, then we want to start with the index 0, and I mean, I'm not sure if it also wants us to output the, if it just wants us to loop up to number nodes, or if it also wants us to output the empty nodes. I think in this case, probably we can just go right to, yeah, let's say less than number nodes, because obviously like if we only insert 3 elements, right, then it's only going to output like those 3 nodes. Of course, if we did 20, well, that's going to output, well, obviously, yeah, left pointer, right pointer data would all be -1 in that case. Yeah, I mean, well, you know, for those for those nodes that we've actually not, you know, let's say not created. Right, and then here we're just going to get index ++. And what we can do, let's just go s out, and I think I'm just going to create a variable because otherwise it's going to be quite long. This is going to be right node, and let's go. I mean, well, let's call it n, and we'll just go right. That's equal to tree, right at this index, and then here we can just go right. Let's go n dot get left, and then let's just have a pipe or something just to separate them. Right, let's go get data. And then of course, finally, let's just go right get right. Okay, so I think that should be okay. And yeah, let's just test that. Then probably let's just remove that breakpoint. And what I'm actually going to do, I'm actually just going to use the same ones, right? So 6, 2, 3, 7, 5, 8. Yeah, see if I can remember that. Right, okay, so yeah, right, 6, 2, 3, right, then 7, 5, 8, and right, then we just want to go right, tree class, and then right, yeah, then output tree, and let's see if this works. Yeah, although, why is it saying the left node is always? I guess that's true because if we actually look at this tree. Yeah, okay, right, so if we look here, well, this 6, yeah, this 6 is actually the only thing that has a left node. Like, I'm going to try just inserting 1, right, just to see if it's actually working. Because, yeah, otherwise that seems a little bit, maybe, strange. Right, let's, run it again. And then, yeah, I guess it's saying 2 is pointing to 6, and then 6 here is going to be the 1. Right, so I think this is working. Now, in this exam, they actually don't ask us to do it, but I will show you how you can actually output the tree in ascending order. So, of course, in this case, it's going to go 1, right, then 2, then 3, then 5, because, yeah, I mean, sometimes they do ask us to do that. So let's just make another one. Let's go public void, output tree, let's say ascending. Now, this is actually going to be recursive. I mean, I guess you could do it iteratively, but I think the way I do it is, well, usually recursive. So the way this works, well, let's just, hang on. Right, let's just do the 1 here. So we're going to start on the root node, and then what we're going to do, well, we're going to call output left, right, on this root node. Then, of course, well, that's going to call, okay, sorry, right, we're going to call output nodes, or output tree on this, left node. Right, then what that's going to do is going to call output tree on this one. And when we get to something that doesn't have a left pointer, well, then we're just going to output the data, which I guess is the 1. And at the same time, okay, we're also going to be calling output right, or well, I guess output tree, right, but on the right node. So like then what's going to happen? So of course, well, this 1 it would have outputted, that's fine. And I mean this 2, well, I mean we've gone down the left node already, that's fine. Right, but then what it's going to do, well, it's going to output this data, which is 2, and then after it's outputted this data, well, then it's going to call output node right on this right branch. Again, this one, well, it's going to check, is there a left branch? Right, no. So then it's going to output the data. Right, then it's going to check, is there a right branch or is there a right node? Okay, of course, well, in this case, yes. Right, and of course, well, then this one's going to check, right, is there a left? No. Right, then it's going to output the data, right, is there a right? No. And of course, well, then it's going to, sort of go back, right, it's going to backtrack up. So, like, I mean, that might sound complex, but I think we'll see it's actually quite simple. Right, I mean, let's just go node. Yeah, I guess we can just call that n. Right, then, yeah, I guess it's saying it doesn't like void, probably. Okay, right, it's because I've not done it inside the class. Yeah, okay, alright, so I think, yeah, of course we do need void. Right, so what we want to do then, we just want to check if n dot, right, let's go get left. If this is not equal to -1, well, then what we want to do, we just want to call output tree ascending. And then right here then I guess we've got to think, well, what is the left node? Well, yeah, I mean, okay, well, let's say, yeah, what is the node we're pointing to? So I guess to get that node, what we're going to go tree, and then the index is going to be what n.get left. Okay, this is the node that the left pointer is pointing to. Right then here, well, this is where we just output the data. So right, yeah, get data. And then as you can probably guess, right, we're then just going to copy this, and we're just going to change this to right. So yeah, let's go get right. And then okay, yeah, that's also going to be get right, and I think that should be okay. And I think, all right, what I'm going to do, I'm actually just going to like, rather than doing print line, let's just go print, and let's just have a let's have a sort of a space character like that. And I'm also just going to, let's say, output some empty lines. Yeah, just something like that. Right, and if we go tree class, and let's go output tree ascending. Now, I suppose the first one, what we need to give this the root node. So the root node, well, that's going to be the tree class, right, dot tree, and then I guess, yeah, 0. You know, alternatively, we could also go a tree class dot first node. Yeah, of course, right, that's, yeah, I mean, that's also going to be 0. Right after we've initialized it. So let's try and run this, right, hopefully it will work. And then, yeah, okay, if we zoom in here, right, you can see I just outputted this in the correct order. Of course, if you wanted to do it in reverse order, well, I mean, probably you can figure out how to do it in reverse order. Basically, we would just put this get right above the get left. So let's just go, yeah, let's go here. And then, of course, well, we're going to have the data in the middle. And then, yeah, this get left should be here. All right, and then that should be reverse order. Let's just check it. And yeah, okay, we can see that's working. Right, so is there anything else? Right, the main program declares an instance of tree class with the identifier, right, the tree. Okay, right, write program code for the main program. Right, I mean, well, then just test it. So, I mean, I think this one, well, I've done this already. Like, one good thing with IntelliJ, let me just show you how to do this. Like, if, for example, we want to change this name, well, I mean, of course, you could do it manually, but you can also go, right, I guess, refactor, right, then rename, and what, let's call it the tree. And of course, then you can see why it's going to replace all of those instances, right, with, yeah, the tree. Question 3 says, a program sorts an array of integers and searches the array for a particular value. The array of integers number array stores the following data in the order given. Right, the array is declared and initialized local to the main program, and write program code to declare and initialize the array. Okay, so let's just copy these numbers then. Right, and then here it said, well, they're going to be, let's say, declared and initialized inside the main program, right? So basically inside our main method. Right, let's go int array, that's going to be called number array. And yeah, let me just fix this u here, right, that should be lowercase. Now, of course, we can go, well, new int, and I think there's 7 of them. So we could go, then of course we assign them individually, like say number array, number array 0, and I think that was going to be 100. Of course, right, that's going to be a bit slow. So instead we can just use, use these curly brackets, and then right, we can just paste all of these numbers in, of course, separate them with a comma. And yeah, this is going to be how we can both, let's say, declare and initialize right, data in one go. So yeah, I think that's okay, right, just for 1 mark. Then the next one, the following recursive pseudocode function sorts the array into ascending order using an insertion sort and returns the sorted array. Okay. Right, okay, so yeah, what we can think then, I mean, like this, we don't really have to understand how it's working, because if we look at this, well, all we want to do is just write the program code for the pseudocode function recursive insertion. Now, I will actually be honest that, well, this recursive insertion function, I mean, this does actually work, but I did try these questions before, and this next one, well, the next one is going to want us to convert this to, let's see, okay, wait, not this one. Yeah, it's going to want us to convert this recursive version to an iterative version using loops. And actually, I mean, their logic for the recursion one, I mean, it doesn't really translate into the iterative version. So, and to be honest, you know, I also checked their code in the mark scheme, and if you just copy and paste their code from the mark scheme, right, either, well, Java, Python, or Visual Basic, and none of them correctly sort the array. Right, so I mean, I will kind of explain how this recursive one is working, like what it's doing, but again, this doesn't actually really work when you translate it to the iterative version. Or at least if you did translate it, I mean, you'd have to add so many like extra flags, extra checks, that yeah, it's just not going to be, I guess, you know, it's not really going to resemble this original recursive insertion. But anyway, I mean, saying that, well, let's probably just go ahead and actually write this. So I think maybe what I'm going to do, I'm probably just going to split screen here. Yeah, just so I can, you know, code side by side. Okay, right, I realise it's not letting me do that because I've got it full screen. Alright, let's try again. Okay, and yeah, let's just move that across a little bit. Right, so it says then, well, this should be a function, so well, this is going to return an integer array. And maybe first of all, let's just declare these three global variables up here. So in Java, well, if it's global, let's go static, since, you know, we're going to be calling this from the main, right, therefore it has to be static. Right, so this is going to be what, an int, and right, this is going to be last item, yeah, and also check item. Right, and yeah, I think we can just leave those uninitialized. Right, then we want to go, so right, this is going to be Boolean, and yeah, just loop again. Okay, then what we want to do, so this is going to be a function, right, let's go, well, public, right, yes, static, and here we want to say it's going to return an int array. Right, the name is going to be recursive insertion. Right, okay, this takes an int array called integer array, and it also takes, okay, number elements. Yeah, I think I'm too used to Pseudocode where, you know, you write the variable name first, right, then the data type, whereas of course, yeah, Java it's the other way around, right, it's data type then the variable name. Right, okay, so well, here then just a simple if statement. Right, let's go if number elements, yeah, if this is less than or equal to 1. And to be honest, I mean, this question is, you know, quite easy, like as long as you don't make any silly mistakes copying and pasting, or yeah, kind of translating. Right, then we want to call recursive insertion, so yeah, let's just call this again. Right, again, this is going to take the integer array, then it takes the number of elements minus 1. And yeah, let me just move this across since we're kind of running out of space here. Right, then we want to, okay, then we want to set the last item. So if we think, I mean, what it's doing then, when it's calling recursive insertion, I mean, I think here we're actually starting on the right, because, well, the number of elements, of course, well, that's, yeah, the size of the array. So what we're doing is, well, we're going to be calling recursive insertion, and this will start on number of elements minus 1. So effectively, in that, well, that's going to start on the rightmost element. And what we're then going to do, we're going to set a last item. So of course, right, this is after we've called that recursive insertion for the first time. So after we've sorted one row, right, then yeah, then we're going to call last item, or like, okay, yeah, we're going to assign last item the value, right, integer array, right, then the number elements minus 1. So we say what this, yeah, this will be basically the, well, obviously, yeah, just the last element in the array. Right, then check item, that's going to be the number of elements minus 2. And then what, I mean, what, so yeah, I'll kind of go through what they're doing here. And to be honest, right, this algorithm is not like a typical insertion sort. Yeah, which is probably why it might be a little bit confusing. Let's say we've got, I don't know, 5, let's say 2, right, 4, 6, and let's say, I don't know, maybe 8. And in fact, or that's kind of sorted, so yeah, let's have 1 here, for example. Right, what we're going to do then, so we're going to be starting on this 1, and because we see, well, this is the number of elements minus 1, right, if there's 5 elements, then of course, right, this is, well, index, you know, yeah, starting at index 0. So the number of elements minus 1 is going to be what, index 4. Right, then the item we're comparing it with, well, that's what they call check item, and check item is what, the number of elements minus 2. So effectively what we're going to be comparing 1 with 6, right, yeah, that's what they're sort of doing here. Right, then, yeah, we'll then just end if, and then what we go, so we set loop assign to be true, yeah, okay, loop again to be true. Right, then we check, so if check item less than 0, So of course, well, this means, right, if we've if we've checked all the items, right, if there's nothing left, because well, what they're doing, of course, well, they're starting on the right and then looping left. So yeah, if they've checked all the items, right, compared all the items, right, then of course we just set loop again equal to false. Right, else. So yeah, of course, well, this means if there's still items to check, right, we say right, so hang on, right, if integer array check item. So this is basically the left item, right, if this is less than the last item. Because if we think here, then like hang on, like what's kind of happening is that, well, we're kind of like picking up this item, right? Almost like we're sort of taking it out of the array. And then the way insertion sort the way insertion sort works is that it's just going to move all these elements to the right, okay, until we find the correct position. So in this case, well, because 1 is less than 6, right, therefore the 6 is going to move to this position. Right, then we compare the next one. So we check what our 4, so in this case, well, 4 is also bigger than 1, right, therefore 4 is then going to move to this position. Of course, well, 2 is bigger than 1, right, 2 moves to this position. 5 is bigger than 1, right, 5 moves to this position. And at this point, since we've called this here, we've just assigned it to this last item. Well, then the last item then gets, you can basically think of it as kind of dropped. Right, so of course it's dropped then into the correct position. So of course, yeah, this becomes 1. Therefore, we can think after the first pass, well, 6 has got moved up to here. Right, 4 has been moved to here. Right, 2 has been moved here. Yeah, 5 has been moved here, and of course 1 has been moved here. So I think that's what they're trying to do with this algorithm. And yeah, let's just load both of these up again. Okay, so yeah, right, that's this one. Right, then we set loop again to false. Because well, what this is checking is it's checking if the left item is if the left item is smaller than the item we've kind of picked up and removed from the array. Well, this means we don't need to swap them, right, because they're obviously in the correct order already. Right, then we just have this while loop. No, wait. Yeah, okay, yeah, alright, we have this while loop. Right, I've kind of got lost with where we are, but yeah, we should be down here now. Right, so well, while loop again, of course we can go while loop again equals true, right, yeah, or just while loop again. Right, we're gonna, okay, hang on, right, what are we doing then? So we have the integer array, right, so the check item plus 1, and that just becomes the current check item. So, this is basically just shifting the left item to the sort of right position. Right, yeah, that's what we're doing. Right, that's going to equal, right, hang on, yeah, I think I can't type today for some reason. Right, yeah, that's going to be what the sort of, yeah, I guess the right item, yeah, obviously the left item gets shifted right into the right position. Right, then the check item just decrements. And of course, yeah, this is because, well, now we're just moving left in the array, as we saw with the example. Right, then here we go. So here we're doing what we've done before. If check item is less than 0, right, we're just going to set loop again to false. Right, then else. Okay, and I think here then we can actually just make this else if. So we check, right, if the integer array, right, the index is check item. So we say, well, if the current position is less than, the sort of item we're comparing with. Right, so yeah, if it's less than last item, then again, right, loop again is going to be false. Right, then after all of that, then we, right, get integer array. Right, we get the check item, right, index plus 1. So we say, well, this... Yeah, okay, so let's say this is the position we found of where to insert it. Right, and then that's going to be the last item. Right, then finally we just return the integer array like that. So going back here just to the example, like in this case I guess what the check item is going to be -1. Right, therefore if we insert a check item plus 1, right, of course, well, that's going to be inserting here at index 0. And yeah, that's where, like we saw, right, we're just dropping this 1 here in index 0. So, right, let's just test that, right, see if it works. And I think this is also probably the next question. So yeah, maybe let's try and sort of combine it into one. Okay, right, why is that? Okay, there we go. Yeah, I'm not sure why it wasn't zooming in. Right, so then what we want to do, we want to amend the main program to call recursive insertion with the initialized array number array and the number of elements as parameters. Right, also output the word recursive and output the content of the returned array. And you might think, well, why do we need to output recursive? Like, because I don't know, I mean, I was thinking, well, like, do we need to, yeah, I don't know, I was thinking, like, do we need to, like, sort these letters or something weird like that? But in this case, well, the reason they want you to do that is because, well, in a minute, they're going to ask us to call the iterative, right? And then they just want us to compare them. Okay, so here then it says, right, we just want to call this, so let's go number array. Right, that's going to be equal to recursive insertion. Right, this is going to be what the number array, and then here, I mean, here we can just go number array dot lengths. And then, yeah, I mean, here it's saying we probably don't need to, okay, right, it's just saying it's never used. Right, now, if we want to output, well, of course, we can just do a simple for loop. Again, I'm just going to use an enhanced for loop, so let's go in n, and right, this is going to be number array. So what this is saying then is saying, I mean, basically, well, for each integer, right, let's call it variable n, right, for each integer in the number array, well, let's just go s out. And I think rather than print line, I'm actually just going to, let's go n, right, and then we'll just go like plus a space, yeah, just to print them all on the same line, and we'll just test it, see if it's working. And yeah, okay, right, so this seems to work. Now, I think the, hang on, yeah, let's just go full screen again. So I think the next question is probably the one I mentioned where, again, the code that they give in the exam doesn't actually work. Well, yeah, the code they give in the mark scheme doesn't work. So, yeah, okay, right, it says the function recursive insertion can be changed to use iteration instead of recursion. Right, we want to write program code for the function iterative insertion to perform the same process as recursive insertion, but using iteration instead of recursion. Right, okay, so let's try and do that then. And I mean, mostly, like, maybe I'll just zoom out so we can see the whole thing right in one screen. Yeah, maybe a little bit more. Okay, so I mean, mostly we can just copy this, right, and then just make some small changes. I mean, of course, you could write it all out again manually, but yeah, I think it's going to be easier to copy. Right, in this case, of course, yeah, I guess we can keep the signature the same. And then the thing that we want to do is, well, rather than calling recursive insertion, right, just taking the integer array, then the number of elements -1, I think basically we can just have a while loop. And yeah, well, we can just decrement the number of elements by 1 each time. And then, yeah, we just want to do that while the number of elements is, I guess really while the number of elements is greater than or equal to 2. Yeah, because obviously otherwise this would be -1 and we can't compare with -1. So let's just try and do that then. We want to go here, let's go while. And yeah, we can also just delete this one. Right, so yeah, let's go while number elements, and this should be, I guess, well, let's say, yeah, greater than or equal to 2. And I'm just going to indent all of this inside here. Right, and I suppose actually we then just want to have a closing bracket there, and then of course we return the integer array at the end. Now, what is it going to tell us? Right, okay, it's already defined. Yeah, so I need to change the name, of course. Right, now, I mean, yeah, let's go through this. So what is it saying here? Right, okay, not updated inside the loop. So, you know, this is why, again, IntelliJ is quite useful, because obviously, well, I wouldn't have spotted this. So let's think about where we want to update this then, and I think we can just update this here at the end, right after we've looped through the entire row. And then what's it going to say here? Right, this is always false. Right, okay. Yeah, because I guess what we're saying then, that, well, obviously, right, if this is greater than or equal to 2, right, therefore that means, well, the check item can be, you know, 2 minus 2, right, and of course, well, therefore, right, 0 less than 0 is, of course, always going to be false. I mean, I think we can, yeah, we can probably keep it, right? It doesn't really matter. Now, I mean, yeah, let's try and sort of walk through, well, see if we can understand what's happening. So again, we're checking, right, this integer array check item, well, of course, this is the left item. And yeah, so, I mean, here then, this last item, this is the one we're kind of picking up out of the array. And then, I mean, yeah, okay, I mean, basically it's just doing what we've done. Let's see if this just works. Because, again, honestly, it's a little bit pointless because actually, I mean, well, the logic that they have in the mark scheme also doesn't work. And the reason for that is because, well, let's just sort of draw this here. Right, I'll try and think of an example that demonstrates this. Let's say we have, yeah, can we think maybe like just 8, right, let's say 8, 4, and 2. Now, okay, so what we're going to do then, we're going to sort of pick 2 out of the array. So let's just sort of, you know, pick this out here. Of course, we see, well, 4 is bigger than 2, right, therefore 4 gets shifted here. Right, then we check what 2 and 8, right, obviously 8, yeah, 8 is bigger, so 8 is going to get shifted here. So after this case, well, our array is going to be 2 in this position, right, then it's going to be 8, then it's going to be 4. But the problem is, right, I mean, now we're not, you know, looking at this element, right, we've actually gone, you know, to this element. So you notice now, well, of course, now it's going to compare 8 and 2, well, 8 and 2 are correct. So this would actually be our final output. But of course, you know, like in this case, it's wrong, right? Because 8 and 4 are not sorted. Yeah, so that's why their logic of looping kind of right to left, right, doesn't really work. But anyway, I mean, well, let's run this and see what happens. Right, so I'm just going to comment that out, and let's just go again. Or in fact, yeah, maybe I'll just copy this really. And right, let's go iterative insertion, and yeah, just see what happens. Right, why is it saying that? Yeah, okay, I don't know, let's just... Alright, yeah, it's saying we're not using that recursive insertion. Right, okay, so yeah, this is actually the answer that the mark scheme code gives. So honestly, I mean, for this one, yeah, you can probably check the mark scheme. Like, I think, I mean, what they've got is basically just this. Like, all you're really doing is just, well, converting this... hang on, yeah, not this one. You're just obviously, well, converting that sort of, you know, recursive call into a while statement. But again, as we can see, I mean, what these ones are sorted, but yeah, because this 22 and 8 have got shifted to the right, therefore, you know, when, I don't know, like maybe we get to this position, we're sort of going left, but of course, yeah, you know, these ones have already been shifted to the right, therefore they're, you know, obviously, well, yeah, obviously now out of order. I mean, right, maybe that made sense or maybe it didn't. So what I'm going to do, I'm actually just going to implement, yeah, I'm just going to implement, you know, insertion sort normally, and hopefully I can get it working, and I'll show you sort of how you would normally do it. Yeah, rather than, you know, using the method that they do in the exam. Right, so let's go our public static. Let's call it maybe, yeah, hopefully working insertion. Right, and then, I mean, this one, I guess we can do the same, right, let's go int, yeah, let's just call it array, and I mean, we don't really need the number of elements. And yeah, I guess, I mean, here we can just go void, because actually, well, I mean, since, you know, yeah, I guess what Java and Python are going to be passed by reference, right, when it's an array by default. In VB, possibly we would have to specify that, I'm not sure. But I mean, right, okay, what I'll do is I'll try and explain how, you know, people would usually do insertion. So let's have an array, I don't know, maybe 5, right, 2, 4, 6, and maybe 1, right, just something out of order. So what we're going to do then, we're going to start here on the second element, and we're then going to check, well, right, is this element, and again, we're going to sort of pick this up out of the array. So yeah, I'm just going to sort of draw it up like that. And we're going to think, well, is the element to the left, right, so this 5, right, is this bigger than the element we've picked out of the array? And of course, right, in this case it is, so yeah, we swap them as we've done before. So now, of course, this is 5, right, obviously, yeah, and well, this 4, 6, 1, they stay the same. Right, then, of course, we're at the end of the array, right, so therefore we have to just drop 2 in this position. Right, then what happened is, well, now we're moving to the right. Okay, so now we're starting on 4. And again, we're sort of picking this 4 out of the array. So let's just draw that going up. And we think, well, is 5 bigger than 4? Of course it is, right? So then 5 is going to go here. Yeah, it just gets, you know, moved into this rightmost position. Right, then, of course, we compare 4 and 2. Well, 4 and 2, that's actually in the right order. So of course, well here then we just drop 4 here. Of course the 2 stays the same. Yeah, the 6 and 1 stay the same. Right, of course, well then we go to the 6, right, we compare with, 5. And of course, yeah, then the 1, right, and just, yeah, compare them. Right, so hopefully that makes sense. Let's just create this for loop then. So we want to start on element 2, or element 1, right, index, obviously 0-based arrays. And then we just want to loop to the final element. So I think here I'm going to call this maybe position, right, you can call it index. Right, the position, well, we're going to start element 1, then we're going to loop, right, while the position is less than array.length. And right, I think that's here, I should have made this an integer array. Okay, that's going to, yeah, let us use this length property. Right, then if we just go position plus plus. Right, then what we want to do then, we want to get the current element, and just obviously, yeah, kind of like lift that out of the array effectively. So right, let's go current element, or yeah, current value. And I think this current element, I mean, this is what they call last item. I mean, that's basically the same thing. Right, and then this is going to be what the array, and then yeah, at this index position. Right, then I think we just want the current index, because well again, what we're going to be doing is, of course, we're just going left, right, and comparing the obviously we're comparing this current element, right, with the current index, and of course, yeah, just going left by 1 each time. Right, so let's go current index, and I think here, well, let's start this at array position. I mean, you could start at position -1. I think, yeah, that in fact, well, hang on, right, not array position, right, just position. I mean, you could start at position -1, but yeah, maybe that might cause errors. I mean, okay, well, let's try just with the equal position first, and then yeah, maybe I'll make it -1, right, if I can get it working. So I guess one thing, well, we want to loop, right, while the current index is greater than 0, because what we want to do, we want to check, right, the array at current index, and let's go actually current index -1, because of course this is the left element, right, while this is bigger than the current element, right, then what we want to do, well, we just want to move the, let's say, position in the current index up, up to the right. So, right, let's go array current index. And yeah, that's going to be equal to, well, array, right, current index, right, -1, like that. And then we just want to decrement the current index. Right, so that should hopefully get us to the correct position in the array. Of course, you're shifting them all to the right, yeah, when they're out of order. Then, of course, we have to remember to, drop back this current element into the correct position. So let's go array, right, this will be, well, in fact, right, hang on, not position, it's the current index. Right, then that's going to be current element. And yeah, I think, again, I mean, well, yeah, I called it hopefully working, so I guess let's just test it, right, see if it does actually work. Right, what have I done there? Okay, there we go. Right, so here then actually this is a procedure, right, so there's not going to be a return type. Right, let's go, yeah, hopefully working insertion, right, that's going to be array, right, not array, okay, no, number array, and yeah, let's just test it. Yeah, okay, alright, so this seems to work. Now, can we do it if we start this at position -1? So yeah, if we make that position -1, maybe here, let's go like that. I guess this can be, what, greater than or equal to 0? Right, this would therefore have to be +1 like this. Yeah, I think we can then make this 0. Yeah, alright, so I think maybe that might work. Let's just test this. No. Alright, I mean, I'm probably just going to ignore that, because again, I got it working the first time. Like, if you do want to use this approach, yeah, I mean, you can probably modify the code, but yeah, I don't want to sit here and keep the video going on and on. And okay, there we go. Right, so yeah, I think that's fine, and I guess here then we just want to call it, right, we just want to output the word iterative, and yeah, output the content and return array. So I mean, basically we've done that, right, of course we just need to output iterative as well. But again, like the weird thing is that actually the code that they give in the mark scheme doesn't actually give the correct sorted array, even though when they take the screenshot they do give the correct sorted array. So I feel like what they did is probably, I mean, they just took the screenshot for this recursive insertion, right, which does actually give the correct answer. Yeah, then of course, they just used the same screenshot for the iterative version, right, even though of course, right, that doesn't give the correct answer. So, something like this, honestly, like if you tried their iterative version and, just couldn't get it to work, then like probably you can just, fake the screenshot, yeah, and or, just write your own, yeah, I mean, just, write your own sort of iterative version as I did. And, when I say fake the screenshot, well, of course, yeah, I don't know, I mean, you can just do a print line yourself, right, just, output the numbers in order. Because like honestly, like I mean, well, when they give code that doesn't even work, right, then it's kind of impossible. But anyway, right, the last question: the recursive function binary search takes the parameters integer array, right, array of integers, right, first, so the index of the first array element, last, right, the last array element, well, yeah, the index of the last array element, and to find, right, an integer search, right, yeah, well, an integer to search for in the array. The function uses recursion to perform binary search for to find in integer array. The function returns the index where to find is stored, or returns -1 if to find is not in the array. Right, we want to write program code for recursive function binary search. So yeah, is that all we have to do? Yeah, okay, because I was thinking like hopefully they wouldn't ask us to convert this to an iterative version as well. Although to be honest, iterative binary search is, well, not too difficult. Right, so let's just go here and yeah, I'm just going to copy these parameters. Right, I guess, I mean, well, since we're using recursion, I mean, yeah, well, I mean, obviously you don't always have to make it a function, but yeah, here they do specify it's a function. Right, so let's go, public static, and right, this is going to be an int array, and I mean, yeah, I think just binary search, right, that's what they call it. So again, right, let's go integer array. Right, the next one, so this is right first, yeah, then we have int last, right, just the index. Right, then int, right, to find. So if we think how binary search works, and I think, I mean, if you saw the other video, I also demonstrated. Right, let's just get the pen here. Now, of course, well, binary search, I mean, it has to be sorted already. So, I mean, this is why, of course, you need a sorted array from the previous question. Right, so what we want to think, like, I don't know, let's say just, I don't know, 1, right, 2, yeah, 3, 4, right, and 5. Now, of course, right, well, first then we're going to start on the first element and the last element, right, then we want to get the mid position. So the mid position, what that's going to be our sort of index, well, obviously this start index, right, plus the end index div2, right, that's going to get the mid. And if we say that the value we're trying to find is bigger than, this mid element, well, then what we can do is we can move the start position, or yeah, the start pointer up to this one. Because of course what we know is, well, if it's bigger than this 3, right, therefore of course, well, we can discount this, right, it's obviously not any of these values. Yeah, and then, I mean, okay, so, well, let's say if it's not 4, right, well, then obviously the start pointer is going to go to here, because, well, we have, right, this index plus, right, this last index, and of course, yeah, we just move it up +1. Right, then if it's not here, well, I think then actually the start pointer is actually going to go to, obviously this case. And here we say, well, if the start pointer is bigger than the end pointer, right, well, that's when we stop, and that's when, I guess, probably we're going to return -1, is that what it said? Yeah, return -1 if if it's not found. So let's just have this base case then, right, if it's not found. And that's going to be, right, if first is, well, yeah, let's say greater than last. Right, so if this is true, well, then we can just return -1. Hang on. Oh, okay, right, so it doesn't return the, right, yeah, of course it doesn't return the array, it just returns, right, the index. Yeah, okay, right, the index that is found. So let's make that int. Right, then let's go else. And here then, well, let's calculate the mid position. So if we go mid, and what this is just going to be, well, right hand equals, right, that's going to be first plus last, right, and then just div2. Now in Java, of course, well, right, this is going to be integer division by default. So if we have, let's say, like 5 div2, or yeah, 5 divided by 2, well, this is going to equal 2. Now, obviously, if you're using Python and actually Visual Basic, I'm not sure, But if you're using Python, what you would then have to round it down. I guess we're just using the int function. So yeah, Python you have to use int like that. Yeah, just as a function to round down. Okay, right. So well then of course we want to think like if it is the correct element. So we can check. Let's go to find. So if to find is equal to array. No, okay, right. It's called integer array. Right at this mid element. Well, then we can of course just return this index. So yeah, that's going to be return mid. Alright, well let's check if it's bigger. So let's say if to find is bigger, yeah, let's say bigger than integer array mid. Right, well then what we want to do, we just want to call binary search again. So let's go return binary search. Right, the integer array, that's going to stay the same. Now let's think then the first or the start index. That's just going to +1. Right, the last index will stay the same. And yeah, obviously the number to find is also going to stay the same. Right, then we can just have an else. Because of course, if it equals, it's going to be here. Right, if it's bigger, it's going to be here. Right, therefore the only other situation is if it's smaller. And if it's smaller, well, let's just copy this because basically it's going to be the same. But of course, rather than plus and 1 here, here then what? And hang on, right? Okay, this is not going to be first +1, right? That's going to be mid +1. And then here, it's going to be mid -1, right? Yeah, and I think that should be alright. So let's just test this. And I think what I'm going to do, I'm actually going to test it with every element in here. So yeah, okay, right. Well, let's get S out. We'll go binary search. And first, let's just try and yeah. And I think I'm also just going to output a new line, just to sort of separate them. Probably just have a new line here because there's not going to be a new line at the end of this. Right. So what we're searching for then, this is going to be number array, and then yeah, right. So then we need to say first, So that's going to be 0. Last, that's going to be the number array. Yeah, number array dot length, and then -1. Right, and then here, let's say we're trying to find -1. So of course, yeah, this is not going to be found. Or we're trying to find 0. Right, and then yeah, I'm just going to test all of them. So right here, let's say we're trying to find 1. Right, then let's go 8. Right, let's go 15. Right, then 22? Yeah, I think 85. Right, let's try 100. Yeah, 644, and let's try something that doesn't exist, maybe 999. And the reason I'm going to test everything, I guess we'll see in a minute, because sometimes with binary search, you can have, let's say, some situations where it is working, but you might have some weird edge case that's, causing some index out of bounds error or something like that. Right, so yeah, that's why I'm just going to make sure just to test all of them. And yeah, we see here, right? Oh, okay, so okay, hang on, this is the insertion that I didn't have. Wait, what just happened there? Right, okay, yeah, let's just comment that out, and I think here then let's use this recursive insertion, because yeah, this one was working, and let's try again. Alright, so is that working? Yeah, it says -1, and then yeah, 0, 1, 2, 3, 4, 5, 6, and then yeah, -1. So I think that's working. Right, then we just want to write program code to call binary search with the sorted array and integer 644 is the search value. Right, output not found if 644 is not found in the array. Right, output the index if 644 is found in the array. Okay, so right, let's just delete all of this. And I think what I'm gonna, yeah, maybe I'll just keep that new line thing. Right, let's store this in an integer, and we'll just say, I know, found index. Well, yeah, just index. Right, and yeah, let's just remove that extra bracket. And then what we just want to check, so we go, what if found index, and I guess what if this is equal to -1. Yeah, or maybe let's make it not equal, right? Let's have the sort of positive, successful case first. Right, then we just want to output the index. Yeah, okay, so let's say, I don't know, yeah, let's say, yeah, 644, right, found at index. And then we'll just go found index. Right, else, I think what just said not found. Yeah, was that the text? Yeah, okay, not found. Right, and well, let's test this, but I think it should be working, since, yeah, we did just test it before. Okay, wait, did I type in the wrong number? Yeah, okay, right, because I've still got this to find as 0. So, right, let's try again. And then, yeah, right, it says 644 found at index 6. Right, yeah, then we just test and take a screenshot. Alright guys, so I mean, yeah, just checking there's nothing else. Because, you know, actually sometimes they have like 3 blank pages, then they just have some random question like on the very last page. So I mean, yeah, you do have to check, right, make sure there's nothing on the back. Right, anyway, I mean, hopefully that video is useful. Probably it's gone on super long, maybe a little shorter than the last one. But as always, right, if you have any questions, just ask in the comments, and hopefully see you in the next video.